now I'm going to be deriving the velocity position function. So start off with the definition of velocity as a derivative. So velocity is the derivative of position in terms of time. Therefore here I'm going to substitute the time. So it's going to be x is equal to a sine wt plus 5. Therefore you put this thing here. It's going to be d t, and therefore a sine wt plus 5. Therefore we take a out of this thing. It's going to be a d over dt sine wt plus 5. And therefore when you derive this one, you're going to derive cos, derive sine, you get cos, you keep the inside the same, you multiply by the derivative of the inside. So this is a variable, this is a constant, so this one becomes 0 and this one becomes w, so it's going to be aw cos. Remember, this is an equation of velocity as a function of time in simple harmonic motion. So now for maximum velocity in harmonic motion, we're going to let this thing equals to 1. Therefore your Vmax will be equal to AW. This is how they derived that equation that I did in the previous video. The specific heat capacity of a substance is the amount of heat per unit mass to raise the temperature of the substance by 1 degree. The amount of heat energy per unit mass to raise the temperature of a substance by 1 degree. What is the intensity of sound with the measured intensity level of 89 decibels? I0 is equal to 10 to the power of negative 12 W over meter squared. The initial and decibels, B is equal to log 10 log I over I0. So we just substitute 89 and therefore your I0 is always equals to 10 to the power of negative 12. You solve for I.